All right, hi. I want to talk to you today about complex numbers. So the basic idea here is I'm going to define a number I to be the square root of -1. This means that if you square I, you get -1 back. And so what this lets me do is this lets me take the square root of negative numbers. So -4, the square root of this ends up being I times the square root of 4, which is 2I. And then if you reverse this, if you take 2I and you square it, you're going to get 2 squared times I squared. 2 squared is 4, I squared is -1, so you get -4 back. So a number like 2I is called a pure imaginary number. And the motivation behind these pure imaginary numbers is using the quadratic formula to solve for the x-intercepts of parabolas that don't cross the x-axis. So, for example, if I want to solve the quadratic equation 0 equals x squared plus 4x plus 5, so the quadratic formula says that x is -b plus or minus the square root of b squared minus 4ac all over 2a. And if you remember, the trick here is you think of this as having the form ax squared plus bx plus c. So then, reading off this, you get a is 1, b is 4, c is 5, and we're going to take all this and we're going to plug it into here. So you're going to get -4 plus or minus the square root of 16 minus 4 times 1 times 5 over 2. That's -4 plus or minus the square root of 4 times 1 times 5 is 20. 16 minus 20 is -4 over 2. And so normally you'd stop here and you'd say, well, there's no solutions because you can't take the square root of a negative number. But we can take the square root of a negative number. The square root of -4 is 2i. And then you think of this as -4 over 2 plus or minus 2i over 2, which is -2 plus or minus I. And so you end up with a number called a complex number. So the idea here is you have some real number a plus or minus, or not plus or minus, plus some imaginary number bi. This number a is called the real part, and this part bi is called the imaginary part. So let's do another one of those real quick. So let's say I have 0 equals x squared plus 6x plus 13. So quadratic formula says x is -b plus or minus the square root of b squared minus 4ac all over 2a, where a is 1, b is 6, c is 13. And so then this is -6 plus or minus the square root of 36 minus 4 times 1 times 13 over 2. 4 times 1 times 13 is 52. And 36 minus 52 is -16. So the square root of 16 would be +4. So the square root of -16 is 4i. And so I get negative 6 plus or minus 4i over 2, and that's negative 3 plus or minus 2i. All right. So that's why I care about complex numbers. Now I want to talk about doing some arithmetic with complex numbers, because what I'd like to do, for example, is I claimed that 2 plus I is a 0 of, so x equals 2 plus I is a 0 of x squared plus 4x plus 5. All right? So let's say I want to plug that in. So that means I'm saying if I've got 2 plus I squared plus 4 times 2 plus I plus 5, that I ought to get 0. All right. So two plus I squared. So 2 plus I squared is 2 plus I times 2 plus I. And we can treat this like any other binomial, and you square it, and we just need to distribute. So I say 2 times 2 is 4. 2 times I is 2I. And then inside here, you've got I times 2 is also 2I, where you typically put the I last. And then I plus I, or I times I, is I squared. Now, note that I squared is, of course, negative 1, so this whole thing is 3 plus 4I. And so this expression up here, then, is 3 plus 4I plus 8 plus 4i not 2, negative 2, duh. Negative 2, negative 2, negative 2. So negative 2, this is embarrassing, negative 2, so that changes these to minus, and this should be 3 minus 4i, and then this is minus 8. Okay. Minus 8 plus 4i plus 5. I apologize for making that mistake. So you end up with 3 minus 4i minus 8 plus 4i plus 5. Okay. So then I combine like terms. So I get 3 minus 8 plus 5 minus 4i plus 4i. This is 0. This is 0. And the whole thing is 0. Let's just repeat it with the other one. So if I take negative 3 plus 2i and I square it, and I add 6 times negative 3 plus 2i, and then I add 13 to that, so negative 3 plus 2i squared is going to be negative 3 plus 2i times negative 3 plus 2i minus 18 plus 12i plus 13. So let's see. Negative 3 times negative 3 is positive 9. Then I do minus 6i. I get another negative 6i, and then 2i times 2i is going to be plus 4i squared. minus 18 plus 13 plus 12i, I should say, plus 13. And so the big thing that's happening here is this 4i squared is actually negative 4. So you get 9 minus 4 minus 18 plus 13 plus negative 6i minus 6i plus 12i. So again, 9 minus 4 minus 18 plus 13 is 0, and this is 0 as well, so you get 0. All right? So in the next video, I'm going to talk a little bit about actually doing the arithmetic out, just sort of in general, if you had some trouble following along with some of this.